very good evening to all my dear lovely students. I welcome you back to your own YouTube channel, Shri Chaitanya Educational Institutes. Welcome back to Sankalp 2.0, where we are studying about chemistry, organic chemistry, for the RE-NEET, which is there on the 21st of June. In the last class, I have talked about alcohols, phenols, as well as alkyl halides. Previous to that, we have talked about hydrocarbons and thermodynamics. Right? So, in today's class, what I will be doing is I will be discussing with you the two very important topics, carbonyl compounds and amines chapter of your class 12th organic chemistry. We'll be doing all the important JEE mains and the NEET PYQs from here so that you feel more confident about this chapter and revise it well with me. So let us start without any delay. Let us look at the first one. The question says, what is the suitable reagent for the following conversions? So obviously the question is coming from preparation of aldehydes, and this compound is a ester. There is only one way you have studied how ester can be reduced to aldehydes, which is using dibal H. Dibal H. Okay. Same dibal H works for cyanide to imines as well. So if you want to go from a cyanide to aldehyde, you can reduce cyanide to imine and then followed by hydrolysis. Same way here, I'll just use dibal H for this. NaBH4 will not work for acid derivatives. Hydrogen palladium will work, but it will send it to alcohol directly. Not in the presence of BaSO4 obviously. LiLH4 will work, but it will send it directly to alcohol. Yes, this is dibal H. Okay. Dibal H. So this is going to work. Diisobutyl aluminium hydride, dibal H. In the presence of water, water is a solvent here. Moving on to the next one. Again, see the similar questions keep repeating every year. This is NEET 21 question, which says, what is the product of the following chemical reaction? You are adding NaBH4 in ethanol. So do not worry about this ethanol. It's just a solvent here. It's just a solvent here. It's not a separate reagent. NaBH4 we know works for aldehyde ketones. It will send them to alcohols. So I'll get a secondary alcohol here. And also it is going to reduce your ester as well. This is the ester. Ester will be reduced to alcohol. So first this bond will break. This will become your CH3OH, one nascent hydrogen to this oxygen, one nascent hydrogen to this carbon. It will become an aldehyde. Further we know NaBH4 will further break your aldehyde. But NaBH4, see very carefully. See very carefully. NaBH4, not LiLH4. NaBH4 does not attack. NaBH4 does not attack on acid and derivatives. Acids and derivatives. So here no attack would occur, as you can see. Be careful. If it was LiLH4, I would have attacked here as well, making a primary alcohol on this side and secondary alcohol on that side. But since it's NaBH4, I will not attack it here. Only this side I will attack and I'll make it a alcohol. Okay, this alkyl will remain as it is. So this is incorrect. Ketone can't say as it is. This is also incorrect. Okay, this is also incorrect here. They have just, reduced this part as well, which is not correct. This is the one which is correct, where the ester is kept as it is and ketone is reduced to a secondary alcohol. Okay, moving to the next one. This is the 2020 question, which says correct match between the first one and the second one would be benzene. For the preparation of benzaldehyde. So in your mind, you should directly go to benzaldehyde topic. When you read your NCERT, special preparations of benzaldehyde are given, where you have studied about etard reaction coming from, toluene. Similar to etard reaction, you can oxidize your toluene using chromic oxide plus acetic anhydride, right? And then you have seen Getterman-Koch reaction from benzene to benzaldehyde. Getterman-Koch reaction, CO plus HCl in the presence of AlCl3. Okay, so when we take benzene and react it with CO plus HCl in the presence of AlCl3 and CuCl2, we get benzaldehyde. So this is the correct match. Benzonitrile. Preparation of benzaldehyde from benzonitrile means benzene attached to C triple bond N. From here, if I want to go to CHO, I have two options. Either I can do Stephan reduction followed by hydrolysis, or I can do dibal H followed by hydrolysis. Here they have talked about Stephan reduction, so I will take P. which is SnCl2 plus HCl, converts it to imine group, and then on hydrolysis it converts to a aldehyde. Benzoyl chloride, this is Rosenmund reduction, as you all know. Whenever we have a acid halide and we want to give it 2 nascent hydrogen and want to convert it to aldehyde plus HCl, you can do Rosenmund reduction, which is hydrogen in the presence of Lindlar's catalyst PDCBaSO4. Rosenmund reduction. So 3 named reaction you can see here. Getterman-Koch, 3 named reaction given in a single question. Such a beautiful question. They didn't even give you the reactants and products. They just asked you for the preparation of benzaldehyde. 3 named reaction got revised: Stephan reduction, Rosenmund reduction, and Getterman-Koch reaction. So this becomes our answer. Right. Moving on to the next one. Zinc amalgam concentrated HCl, another named reaction. Clemenson reduction, which only converts your aldehyde ketones to corresponding alkanes. So I can see a ketonic group here. It will be converted to a methylene group, means 2 hydrogens will go to this carbon, 2 hydrogens will go to this oxygen. So it will become CH2CH3. This is also a ketonic group. So I'll give 2 nascent hydrogen to this oxygen, 2 nascent hydrogen to this carbon. So this side becomes CH2CH3, not 1 carbon, but there are 2 carbon, CH2CH3. This side also CH2CH3. B option is absolutely correct. B option is absolutely correct. Right. Here the problem is they have put a OH. If you had taken LiAlH4, then this would be the answer. LiAlH4, NaBH4, or hydrogen in the presence of platinum, this would be the answer. Okay. Moving on to the next one. Choose the correct answer from the option given below. Let us see. This compound is getting converted to 2 moles of a ketone, which is nothing but reductive ozonolysis. Ozone in the presence of zinc plus water. Okay, reductive ozonolysis. So A matches with, A can match with 4th option. A can match with 4th option. A could also have matched with KMNO4 in acidic medium, but that option is not there here. Oxidative cleavage with KMNO4H+ also converts your double bonds into ketones or carboxylic acid. We have already discussed this in the hydrocarbon topic. If you have not watched the video, I would request you to watch that as well. So we are converting a benzene into a benzophenone, which is Friedel-Crafts acylation. Friedel-Crafts acylation can be happened from the first one. Friedel-Crafts acylation. Right. Next one, you are taking a secondary alcohol to a ketone. You can use a strong oxidizing agent or a weak oxidizing agent, your wish, as we did in the last class. So I can use KMNO4, or I can also use CrO3. Okay. And then the last one is you are converting a alkyl benzene to benzoic acid. This year's NEET question as well, NEET 2026. Vigorous oxidation with KMNO4 is required here. So vigorous oxidation with KMNO4 in the presence of KOH finally gives you potassium salt of benzoic acid. Okay, it's a nice question. Again, different oxidizing agents have done different oxidations here. So matches with 1, 4, 2, 3, which is B option. Right. I hope it is making sense to you. And now let's move on to the next question. Another beautiful question. This is Rosenmund reduction. Just now we had talked about Rosenmund's reduction. Okay. So it is going to give you the preparation of aldehyde RC double bond OH. This bond will break. 1 nascent hydrogen goes here. 1 nascent hydrogen goes here. So we get our benzaldehyde or the aldehyde, which is option C. Moving on to the next one. Let's look at this question now. Which reagent gives the following transformation? You don't want to touch your alkene, means don't use any hydrogen gas, otherwise hydrogen gas would add here by electrophilic addition. You don't want to touch your alcohol as well. Okay, so alcohol is also not reduced. Only the ketone has been reduced to a methylene group. Ketone to alkane. Ketone to alkane. which is nothing but I can use zinc amalgam HCl. But the problem with zinc amalgam HCl would be HCl can attack here and add by Markovnikov rule. HCl will attack here as well and do the Lucas test here, means OH can be replaced by Cl. So that is the problem. We should not use the Clemmensen reduction here. Otherwise, OH will also get disturbed and pi bond will also get disturbed. So best option is Wolff-Kishner reduction here. Okay, so the alcoholic group, OH group, and the alkene group, olefin group, these two are acid sensitive group. Okay, OH group and olefinic group are acid sensitive group, means they get attacked by presence of HCl. So we should never do Clemmensen reduction if we want them in the final product as well. Okay, so we'll do here Wolff-Kishner reduction. So this is the one. Next one, reduction of aldehyde and ketone into hydrocarbons using zinc amalgam and HCl. Again, just now we have studied this is going to be Clemmensen reduction. Okay, zinc amalgam in the presence of concentrated HCl, Clemmensen. Okay, other ones are not there in your syllabus, only Cope reduction, Dow's reduction, Wolff-Kishner already we know. Next question, let us see, a very good question again. What is the major product obtained from the following reaction? I can see a carboxylic acid group here. First thing when you do any question is identify what are the functional groups present. Then look at the reagent. Once you have identified the functional groups present, then in your mind you should go to that particular chapter. That what did I study in that chapter with this reagent? Then you can think easily. Carboxylic acid, diol H, we have never studied any reaction between them. So nothing happens. This is a ester group if you see carefully. COOR. So it's a ester group. Ester group do react with diol H to become aldehydes. Correct? Plus alcohols. So what will diol H do? It will provide two nascent hydrogens for the reduction. Okay. Carbonyl oxygen bond will break this one. One H goes here, one H goes here. So finally this will become a OH group like this. And here I'll get a CH2CHO, CH2CHO like this. So this is a correct one, this is a correct one, and COH is not touched, it's a correct one, option A. Right? We reach to option A. Other ones don't look correct, so A option is the final answer. Next one is identify the final product D obtained from the following sequence reaction. It's a very recent question as you can see. Let us find out. So we are starting with a acetaldehyde and we are doing a reduction with LiLH4. We know all the aldehydes give primary alcohol with LiLH4, so we get ethanol CH3CH2OH. Chapter name alcohol. From alcohol H2SO4 170 degree, alkene we get CH2 double bond CH2. Okay, dehydration reaction. Plus HBr, which is Markovnikov addition. At any one carbon you can add the hydrogen. At any one carbon you can add the bromide. So we get this. And then what is this reaction? All of you know, whenever alkyl halide chapter sodium diether is written, means Wood's reaction. If one of the aryl halide is also written, I'll call it Fittig also. So it's a Wood's Fittig reaction. Wood's Fittig reaction where the 2 moles of sodium will react, 1 Br will go from here, 1 Br will go from here. This phenyl group attaches to the ethyl group. So we get ethyl benzene, which is option B. Okay. What is the final product they are asking? So which is option B. This also will be a minor product. It's a self-Fittig reaction. It's a self-Wood's reaction. This also is possible. A is not a possible product also here. Okay. So B will be the final answer. Next question is from 2023, as you can see again from NEET 23. Identify the major product obtained in the following reaction. What do we have here? I have a aldehyde group. I have a ketonic group. This is a ketone. This is a aldehyde. Right? And we all know whenever we see AgNH3 twice, what is this? What is this reagent? Tell me. Okay, what is this reagent going to be? This is going to be Tollens reagent. Tollens reagent. mean it's an oxidation reaction again. Tollens reagent react with all types of aldehydes to give you carboxylic acid and silver mirror. So major product will be a carboxylic acid here, but no effect on ketone. No effect on ketone, right? So this is ketone, but this is alcohol. This is reduction we have done, not correct. This is alcohol, alcohol. This is not a reducing agent. And the answer will be the fourth one, where ketone remains as it is. And your aldehyde gets oxidized to sodium salt of carboxylate. And silver mirror would form. Here the Ag will get reduced to Ag0. Silver mirror test. Again a named reaction, Tollens reagent test. Silver mirror test. Moving to the next one. What is the major product of the following conversion? Again a beautiful question. NaBH4. See how many times you have seen NaBH4, LiLH4, dibal-H or Stephan reduction getting repeated. Most important reactions of aldehyde ketone chapter is reduction, oxidation, reduction, oxidation. If you make a small flow chart or if you make a small table of all the reducing agents and what do they do with every reagent, with every substrate, would be a great help to you. Okay. So NaBH4 attacks on ketone. Yes, this is also a ketone. Yes, both will convert to alcohol. But then second step may H2SO4 heating. So first step, what would happen? Both would convert to alcohol. Here also a secondary alcohol. Very nice question. Here also a secondary alcohol. Right? And the next step is concentrated H2SO4 heat means dehydration. Beta, whenever you get a diol and you do its dehydration, always try to go for a conjugated diene, which will be the most stable product. Okay. So here as I can see, I am getting a secondary carbocation. It's a E1 mechanism. It will not any do further shifting and it will make a alkene here, the ZZF alkene. So first alkene comes at this position. First alkene comes at this position. And then second time, this OH will get removed and carbocation will be formed secondary. Then carbocation will undergo shifting to become, stable. So one hydride shift I will do, which makes this carbocation very, very stable. Now I have to do the elimination. So what I can do is, to make it a very stable alkene, I can put one pi bond here as well. So beta deprotonation from this beta hydrogen I am doing. So beta carbon I am doing. So we are getting this particular product, which is a conjugated diene. This is not conjugated. This is not conjugated. This is the conjugated one, A. Okay. Very beautiful question from 2023 NEET paper, right? A special NEET paper which happened in Manipur. This question came, a very nice question, a very interesting question. Okay. So many could do a mistake here, but this is the nice one. So you can remember this to how to do dehydration of diols. Incorrect method to synthesize benzaldehyde. From where the benzaldehyde cannot be prepared. First one is when cyanides are attacked by Grignard, we know it's a preparation of ketone. Here CH3 minus would attack on this carbon. So we get C, here a CH3 has attacked. On hydrolysis, this will become a ketone. So acetophenone we are getting. So incorrect. A is incorrect. What about next? Next is correct only Rosenmund reduction. Next one is dibal-H, just now we have done. Again repeated question. And last one is, this is Etard reaction. Etard's reaction to prepare benzaldehyde. So all of them will give benzaldehyde except the first one, which is giving us acetophenone, right? Let's move to the next one. Compound X on reaction with ozone followed by zinc, means ozone lysis, gives formaldehyde. So one of the product is formaldehyde and the other product is 2-methyl propanol. 2-methyl propanol, I am just drawing it. This is propanol. Okay, this is 2-methyl propanol. These two products are being obtained. If I can easily see why these products are obtained, I can think that ozone lysis would have happened. There would be a double bond between this carbon and this carbon. And then due to that breakage of double bond, oxygen would have come here. So if I put a double bond here, I get a CH2 double bonded attached to this carbon, which has a CH CH3 and CH3. So what is this compound going to be? It is going to be a 3-methyl but 1-ene. 3-methyl but 1-ene. Okay. Moving on to the next one. Identify the X in the following sequence of reaction. First step is going to be, okay, halogenation. If your halogenation was done one time, let's say, for example, if halogenation was done one time, you would have gotten benzyl chloride. Then benzyl chloride on reaction with water would give you benzyl alcohol, but you didn't get benzyl alcohol here. You got a benzaldehyde. That means to get a benzaldehyde, I should have done dichlorination here. This is commercial preparation of benzaldehyde in your NCERT. So dichlorination, if I do, Cl2 2 equivalents in the presence of sunlight. And then if I do hydrolysis, you know, one OH will come here, one OH will come here, and 2 OH on the same carbon are never stable. Vicinal geminal diols are never stable, so they automatically undergo dehydration like this. H2O will be removed and we get benzaldehyde. That means it's a dihalide that we should obtain here, which is option B. Okay. If the final product was given to you as benzoic acid, that means a trichloride would be there, because if 3 chlorines are there, then 3 OH on a same carbon will be unstable, finally gives you carboxylic acid. So hydrolysis of trihalides, geminal trihalides give you carboxylic acid, dihalides give you aldehyde, monohalide ka hydrolysis would give you a alcohol, benzyl alcohol. Moving on to the next one quickly. Reaction with benzaldehyde cannot be prepared. Reaction by which benzaldehyde cannot be prepared. Benzaldehyde can't be prepared. See how many times they have asked about benzaldehyde. If you see, just now I have discussed around 15 to 20 questions. Out of those 15 questions, benzaldehyde has been asked at least 7 to 8 times. You can think how important this is, bhaiya. So benzaldehyde cannot be prepared by which reaction? First one, just now I've told you, see, same to same repeated question they keep asking. This is Rosenmund reduction, I can prepare benzaldehyde. This is which one? Tell me. Gattermann-Koch reaction in the presence of AlCl3 would be written here. Benzoic acid, Clemmensen reduction. We know that acids never react with any Clemmensen, so nothing will happen here. No reaction will happen. Last one is which one? Etard reaction. Etard's reaction. Okay. So this is C option. Same to same questions get repeated almost year by year. Next one is aldol condensation product of cyclohexanone on heating followed by heating. When heating is mentioned, we know we make a alpha beta unsaturated product. How do you make a product? Very simple. Do it by the gun and hands mechanism. Okay. So what you do is take 1 mole of aldehyde or ketone and show a gun from his side like this. So one aldehyde is holding the gun like this. Other aldehydes will do hand raise like this. He will raise hand like this. Okay. Once he has raised hand, just remove water from between. So this is the gun. Other one raises the hand. Hands are going to be nothing but the alpha hydrogens. Only if 2 alpha hydrogens are available minimum, then only condensation can happen. Otherwise, aldol formation only can happen. Okay, so when you heat it, just remove water like this. It must be alpha hands, not the beta. As we know, aldol condensation is a application of acidic character of alpha hydrogens. So I get this product. If there was no heating given, without heating if the question was given, if no heating was there, if they were given NaOH, just NaOH is given, for example, then you can draw the same product and just add water into it by putting a OH on the beta position. So I am writing a beta hydroxy ketone, which is a aldol or a ketol. This is alpha, this is beta. Just put a OH on the beta. This is no heat, this is after heat. Okay, so both the products I have told you how to make. Gun, hands, remove water, If no heat, add back water by putting OH on the beta position. Since there was heating here, option A would be the correct answer. Okay. Ozone-lysis reactions, you can easily predict the product. First thing you do is check which is not alpha beta unsaturated compound. If any options you see that they are not alpha beta unsaturated, directly keep them aside. Okay. So this is the one. This is how to solve. Next one. Which is most reactive towards nucleophilic addition reaction? Nucleophilic addition. We always know that there are two factors, which is electronic factor and steric factor, which both decide that aldehydes are more reactive than ketones. Aldehydes are more reactive than ketones in nucleophilic addition reactions. Okay. Alright, so this is an aldehyde, it is reactive aldehyde. This is a ketone, so I'll directly cut it. This is the aldehyde. So A, C and D, three options we are left with now. Now because a nucleophile is coming to attack, nucleophile is electron rich. Okay, so more electron deficient your carbon is, nucleophile can attack easily, like a Cn minus. So this NO2 group, which is a minus M group, would be pulling electron from this carbonyl, making this carbon-oxygen bond very, very polar. Too much positive charge it will create on carbon. This will be highly reacted towards a nucleophile like a Cn minus. Cn minus would love to attack here. Cn minus would love to attack here. Okay, Cn minus would love to attack here. But here it will not be good because CH3 is sending the electrons by plus H, making this carbon very, very, very little positive. It will not be reactive. So it will be unreactive. This will be highly reactive. This will be also reactive only, but as not as good as D, but still reactive. And B is the worst because it's a ketone. So D becomes most reactive. So for a nucleophilic attack, remember it. For a nucleophilic attack, on a ketone or a aldehyde or a ester or a amide or a acid halide, whenever you are doing a nucleophilic attack, the substrate should be more electron deficient. That's why if you remember Dow's process, when you took trinitrochlorobenzene, that was very reactive towards the Dow's process because again the same reason, electron withdrawing groups increase the reactivity of nucleophilic attack. Predict the product in the given reaction, 50% KOH is written. As soon as you go to aldehyde chapter and think what reaction happens in the presence of KOH, it is either aldol or Cannizzaro. Aldol is not a possibility here because there is no alpha hydrogen. So it has to be a Cannizzaro reaction, which is self-reduction, self-oxidation. Nothing will happen to chlorine. Nothing happens to chlorine because we know that there is a partial double bond character here. So aryl halides are not reactive towards KOH in general. Now, if they gave you like 300 atm pressure and 623 Kelvin, you could have substituted this. But in this case, nothing will happen because just 50% KOH is mentioned. So just do a self-reduction and oxidation. So it will become benzyl alcohol and benzoate. Benzyl alcohol, but this is not correct. This is acetate group. Benzyl alcohol, this is not correct. This is phenol group. Benzyl group, benzyl alcohol and benzoate. Chlorine remains as it is. C is your answer. Not D, because I told you that due to double bond character, the chlorobenzene will not get converted to phenol, but only the benzaldehyde will undergo the self-reduction oxidation. Now we'll go to the next topic, which is going to be the nucleophilic addition of aldehydes followed by dehydration, which is the second type of chemical properties in your NCERT. Reaction with hydrazine to give hydrazone. What sort of reaction? It is a nucleophilic addition elimination reaction. As soon as you go to the chapter aldehyde ketones, in aldehyde ketone there is no electrophilic addition possible. There is no free radical addition possible. There is no electrophilic reaction possible. All the reactions are nucleophilic addition only. Okay, so D. Order of reactivity towards phenyl magnesium bromide, again a nucleophilic addition reaction. Who would be more reactive towards nucleophilic addition? Tell me. I told you already, aldehydes are more reactive, so one is the best. Okay, and then the phenyl group, means the benzophenone, will be very, very less reactive here because of both the reasons. One is steric reason, benzyl group will be very bulky. Other reason would be electronic reason. Here ketone is a minus M group, we know. So we can easily say that the the phenyl group is a plus M effect like this. It is sending electron here, making it very unreactive towards nucleophile. So one is the best because aldehyde, then two because ketone, and third very, very bad because of plus M effect of phenyl rings. Least reactive. 1, 2, 3. Last option. Moving on to the next one. Which of the following on treatment with 50% aqueous NaOH? 50% aqueous NaOH written means directly you can think of Cannizzaro reaction. Yields corresponding alcohol and acid. Cannizzaro reaction. Yes, A will give. A doesn't have alpha hydrogen. So the question was of checking no alpha hydrogen in aldehyde. Only aldehyde, no ketone. Second one has alpha hydrogen, so it will give you your aldol condensation product. Next one is a ketone. Ketone never give you Cannizzaro reaction. They will give aldol only. This also has alpha hydrogen, so this will also give you aldol condensation. Moving on to the next one. Again, same question. I want you to answer it. This is homework question number 1 for you today. I have just told you how to do these type of questions. Where do you think nucleophilic addition reaction will take place fastest? Okay. Answer it. I am waiting for your answer in the chat box and also in the comment section in case you are watching this video not live. Okay. Next one. Iodoform test is not given by iodoform reaction, which is an oxidation reaction. It is given by methylated secondary alcohol groups, secondary or primary, or methylated carbonyls, only ketone and aldehydes. 2-pentanone has a methyl group attached to CO, it will give. Ethanol is a primary alcohol which has a CH3CHOH group, so it will also give. Ethanol will also give because it is also a aldehyde ketone carrying a CH3 group. 3-pentanone will not give because there is no methyl group present on both sides. It's the ethyl group which is present. So this one will not give the iodoform test. Next one. Which one does not give benzoic acid as the major product? NEET 2019. This year also similar question was asked, where the vigorous oxidation of this gives you benzoic acid. Here they have done chloroform test. NaOCl means Cl2 plus NaOH. Haloform test, which will give you benzoic acid, which will break this bond. CH3 would come out as CHCl3 chloroform plus benzoic acid after hydrolysis. Okay. They are asking who will not give benzoic acid. First one, KMNO4, this will give benzoic acid. Any primary alcohol with a strong oxidizing agent will become acid. K2Cr2 same reaction, it will also give acid. This will not give acid. PCC is a particular mild oxidizing agent which converts your alcohols to aldehydes only. Okay, last class also I have told you the same. C will give you benzaldehyde and not benzoic acid. Now let us look at the next one. So again a chain reaction type question. CH3COH SOCl2. So first thing what SOCl2 does is it removes the OH, puts a Cl. So A is CH3COCl. Reaction with benzene in the presence of anhydride AlCl3, anhydrous AlCl3, which is nothing but a Friedel-Crafts acylation. From here AlCl3 takes away Cl minus, giving you a acylium carbocation, acyl carbocation attaches to benzene. So we get acetophenone. HCN, nucleophilic addition reaction. Cn minus attacks here, O becomes OH, we get a cyanohydrin. So C is a cyanohydrin, where this carbon who has a CH3 gets a Cn also and OH also, cyanohydrin. And then hydrolysis, which converts cyanides directly to carboxylic acid. Another very good example where we have prepared alpha hydroxy carboxylic acid like a lactic acid. It is like a lactic acid. It's a extra phenyl in a lactic acid. If this phenyl was not here, it was lactic acid, alpha hydroxy acid. Okay, which is your D option, alpha hydroxy acid. Don't choose option A by mistake. This is extra carbon here, but our final product is this product. It's a chiral product, so answer will be a racemic mixture here. 50% D plus 50% L. NCERT nicely writes, nucleophilic addition on aldehyde ketones always give rise to racemic mixture because aldehyde and ketones are, planar in nature, just like carbocation. So when the nucleophile comes to attack, it can attack from the front of the board or from the back of the board. If the final product is having a chiral carbon where the attack has happened, you can always write racemic mixture. That also a question could be asked, statement type. Similar question as the previous one, exactly the same. I want you to write the product C in the chat box. Homework question number 2. Tell me which answer will be there. Take 2 minutes, pause the video. Okay, do it yourself. I know all of you can do it. All of you are capable of doing all these questions which we are giving here. And these are all NEET level questions. So you should feel confident after doing such questions. I want you to answer it and tell me in the comment box. What is the major product P? Now we are coming towards the carboxylic acid chapter. There is a phenyl magnesium bromide, means there is a Grignard reagent which is reacting with carbon dioxide. Carbon dioxide also behaves like ketone aldehydes only. It provides an electrophilic carbon for the nucleophilic attack. Like this phenyl will attack, this will become O negative, which gives you phenyl carboxylate. And on hydrolysis, it will give you benzoic acid. So this is benzoate and we get finally benzoic acid. So remember it, whenever Grignard attacks on CO2, you get acids. Tell me as a homework question number 3, what happens if Grignard attacks on HCN followed by hydrolysis? I'm waiting for your answer in the chat box. You need to tell me the name of the product when Grignard attacks on HCN. Okay, is it benzoic acid? Is it benzyl alcohol? Is it benzaldehyde? What type of reaction it is? Tell me what is the product in this one. Moving on to the next one. Again, see, now we look at the question, you might feel, sir, we have to not study esters, but I just told you the concept. Whenever a nucleophile is coming to attack, alkaline hydrolysis, alkaline means OH minus is coming to attack. Who is coming to attack, bache? OH minus, alkaline hydrolysis. What is OH minus? OH minus is a nucleophile. So it's a nucleophilic attack. They are saying which ester has the best nucleophilic attack. Decreasing order we have to tell. I told you, you just need to check electron deficiency of carbonyl carbon. If carbon is more electron deficient, it will be highly reactive. Now, as soon as I see any NO2 group somewhere, I see a NO2 here, making this carbon very, very reactive. Very positive carbon, so OH minus would love to attack here. If I see a OCH3 group, which is the plus M group, it will send electron and it will make this carbon very, 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 very little positive, which is very much unreactive. Cl is overall a minus I group. It is also kind of reactive. And no effect means somewhere in the middle. So who becomes the most reactive? 3. Who becomes the least reactive? 4th. So this is wrong. This is the answer. 3, 2, 1, 4. Okay. I hope it is clear to everyone. Any question like this repeats, please do not do a mistake. Next one. This is a question which is very interesting one that you might not have seen before, but it came, and when the question comes new type, you need to think of the mechanism yourself. You have to sometimes derive the mechanism yourself. Okay, so this is that type of question that we are talking about here. What happens if HCHO, HCl react with benzene? This reagent you have never seen. Am I right? You have not seen this particular reagent. What would happen? Let us see. We know benzene is an electron-rich species. Benzene is an electron-rich species. Now, if I react with HCHO, HCl, what would happen? HCHO, which is formaldehyde, plus HCl. Think, this is an electron-rich person. If we could generate an electrophile somehow, then we can easily attack benzene on it. Let us see. This is our aldehyde. Whenever aldehydes are in presence of HCl, you should remember that in the reactions with the, just a second to check. In the reaction with alcohols, where the dry HCl gas was used as a catalyst, we have created a partial positive carbon in that case. So same thing would happen here. As soon as you take HCl in the presence of aldehyde, here this oxygen can attack on this partial positive hydrogen like this, and Cl minus can go out. Correct? So what do I get? I get HCOH hydrogen like this, O positive. Now, as soon as this oxygen gets a positive charge, we know oxygen is highly electronegative. This pi electrons shift here, making this carbon a carbocation like this. So, CH2OH carbocation I have produced. Now, what will happen? The benzene will attack on it like a electrophilic substitution, how benzene does every time. Benzene attacks on CH2OH and you get benzyl alcohol. Very nice question. So we get a benzyl alcohol. Okay, benzyl alcohol. Since you have the presence of HCl also here, then benzyl alcohol further can convert to benzyl chloride. Benzyl alcohol further can convert to benzyl chloride. I hope it is making sense to you. First I got benzyl alcohol. Reaction of alcohols with HCl, which is nothing but Lucas test. SN1 reaction. SN1 reactions are highly feasible when the carbocation is stable. I can see the benzyl carbocation is super stable. So it gives us benzyl chloride. And then we are reacting AgCN. AgCN we know is a covalent compound which attacks from the nitrogen side and we get isocyanide. Benzyl isocyanide. Okay. So very nice question. So A is a benzyl chloride and B is a benzyl isocyanide. Very, very interesting question where we had to think of the mechanism by our own self, that when formaldehyde reacts with HCl, it can convert to CH2OH carbocation, which attacks on benzene, gives you benzyl alcohol. But we know benzyl alcohols do not give any reaction with AgCN or KCN because OH minus is a very poor leaving group in that case. So first we'll do reaction with HCl, giving you Lucas test to give benzyl chloride, and then we can react with AgCN. Okay, I hope it makes sense to you. So this is our next question. Next question is this one, where an alkene chapter is reacting with HBr in the presence of benzoyl peroxide, which is anti-Markovnikov addition. I'll give you a hint of these reactions and I want you to tell me the answer in the comment box as homework question number 4. Okay, so anti-Markovnikov. KCN is a nucleophilic substitution where Br will be substituted by Cn minus, and then sodium amalgam ethanol, which is a reducing agent which converts cyanides to primary amines. Okay, cyanide to primary amine. So this is a reducing agent which converts cyanide to primary amine. Again, NEET 26 similar question was asked. Which of the reagents can convert cyanides to primary amines? Sodium amalgam ethanol can do that. Hydrogen in the presence of nickel can do that. And LiAlH4 can do that. Okay, so I need you to tell me the answer in the comment box for homework question number. You can take some time and solve it. Moving on to the next one. Now we are into the aniline and the amines chapter. Benzene diazonium salt is prepared by reaction of aniline with nitrous acid, which is HNO2, which is nothing but HNO2 is unstable, so we prepared it in C2 by taking sodium nitrite in the presence of HCl. At 0 to 5 degrees Celsius, it's absolutely correct. It decomposes easily in the dry state. It's absolutely correct. Diazonium salts are very unstable, only stable at 0 to 5 degrees Celsius. Insertion of iodine into the benzene ring is difficult, and hence iodobenzene is prepared through the reaction of benzene diazonium salt with Ki. It's absolutely correct reaction. Direct iodination of benzene is a very slow reaction. In the in the chapter, aromatics you have studied, direct reaction of iodine is very slow and reversible in nature. So we use something like a HNO3 to send the reaction forward here. Not a great reaction. The better way is you first convert your benzene to nitrobenzene. Then you can reduce your nitrobenzene to aniline. Aniline ka diazonium. Then attack Ki on it, which is a very good reaction. So both the statements are absolutely correct. Moving on to the next one. Right. Gabriel synthesis, which is Gabriel thalamide reaction. Whenever we take a thalamide, what is a thalamide? It is a cyclic amide of phthalic acid. And when we prepare its potassium thalamide salt and we attack it on a alkyl halide, it's a SN2 reaction where we get a primary amine as the final product. So R gets NH2, finally we get a RNH2 after a hydrolysis. So Gabriel synthesis produces primary amines. Kolb synthesis. Kolb synthesis is a Kolb's carboxylation reaction on a phenol when you react it with NaOH followed by attack of CO2. We get salicylic acid after hydrolysis. It's a preparation of salicylic acid. Another named reaction, a good reaction, salicylic acid. Williamson ether synthesis already we have studied, so it gives ethers. Etard reaction already we have studied, so it gives you benzaldehyde. Another question from the 4 different named reactions. NEET 2022. I've already told you about diazonium salts. Homework question number 5. I want you to answer in the chat box. What do you think of question number 5? Quickly. Primary aliphatic amines react with HNO2 to give unstable diazonium salts. Primary aliphatic amines we are talking about, not aniline here. Okay. Primary aromatic amines react with HNO2 to form diazonium salts which are even stable above 300 Kelvin. Let's see. Let's see what all of you will answer. I will check your answers in the chat box for sure. Next one. Identify the compound which will react with Hinsberg reagent. What is Hinsberg reagent, bache? It is a reagent used to test for primary, secondary, tertiary amines. This is Hinsberg reagent. Benzene sulfonyl chloride. Whenever we react Hinsberg reagent with a primary amine, RNH2, whenever we react with the secondary amine, RNHR, primary amine, first H goes from here, Cl goes from here, gives you a sulfonamide which is acidic in nature. We call it N-alkyl sulfonamide. And because of this acidic proton, it is soluble in NaOH. But the question is, who gives a solid which dissolves in alkali? Means it is soluble in NaOH. So they are asking for a primary amine for the reaction. When a secondary amine reacts, HCl goes out, we get an NN dialkyl benzene sulfonamide, which doesn't have an acidic proton. Hence, it is not soluble in alkali. They are asking soluble in alkali, secondary, primary. Primary will be soluble in alkali. We can easily distinguish between primary, secondary, and tertiary using Hinsberg reagent. Tertiary would not even react with the Hinsberg reagent because there is no proton available to react with this chloride. Next one. What is the reagent R in the following sequence? NH2 was there, we converted it to diazonium salt, N2 plus Cl minus. And then we have removed this. Very important question, NEET 2021. Whenever you want to reduce a diazonium, you can use 2 reagents. If you want to reduce a diazonium to just a phenyl group or a benzene ring, either use H3PO2 or you can use ethanol. These are 2 reducing agents which work here. So ethanol is given here, H3PO2 is not given here, gives us the final answer as ethanol. Okay, I hope it makes sense. Moving to the next one. Who will give a carbylamine test? Very important test to detect a primary amine. Whenever you take a primary amine like this one, it's NH2, sorry, not NH3. Whenever you take a primary amine like aniline, whether it is aromatic or aliphatic doesn't matter. When we react it with chloroform in the presence of KOH, chloroform in the presence of KOH in 1:3 ratio, we get a very bad smelling compound which is isocyanide and triple bonds. Bad smelling compound. So fourth one can make a isocyanide by a carbylamine reaction. Okay, isocyanide test you can call it, carbylamine test also you can call it. Bad smelling compounds, isocyanides are produced. Just now I gave you the reasons for Hinsberg reagent and I gave you the reaction. This becomes your homework question number 5. Tell me in the chat box what would be the answer. I want all of you to answer in chat box or comment box and like this video and subscribe to the channel if you are enjoying the video till now. Okay, so that we get more motivation to make more content for you like this. So like this video, subscribe to the channel and tell me in the comment box what would be the answer for this one. Who gives a compound which is insoluble in alkali? P2019 question. See, simple questions only NEET asks. Organic chemistry in the NEET has never been tough. It is always NCERT based, always simple and never complicated. Moving on to the next one. Okay, electrolytic reduction of nitrobenzene in strongly acidic medium. This is not there in the syllabus anymore. Okay, not there in the syllabus anymore, but you can remember it if you want, that when you take a nitrobenzene in weak acidic medium, if you do electrolysis, or in a strong acidic medium, if you do electrolysis, weak acidic medium is just like Sn plus HCl, you get NAD. But in strong acidic medium, you get NH2 on the top and OH at the para position. Okay, this is one extra thing which is not there in the syllabus anymore. If you want, you can remember it. Para aminophenol is the final product if I take strongly acidic medium. Moving on to the next one. The set of reactions are given. Okay, it is a very important reaction, which is as soon as I see NaOH plus Br2, I should either think of, haloform reaction if I have a methylated ketones or primary alcohols, or I should think of Hofmann bromide degradation. Happy birthday reaction. Hofmann bromide degradation, which converts primary amides to primary amines with 1 carbon less. Okay, let's look at this reaction now. SOCl2 already we have seen, COOH goes out, COCl will be there. This becomes an acid halide. Ammonia. So you might not have seen this reaction directly in the NCERT, but you can see here this is partial positive carbon and this is a nucleophile. It's a nucleophilic substitution that we are doing here. Acid halide can be easily converted to amide by reaction with ammonia, right? And then, as I can see, it's a primary amide here. So the last reaction is a Hofmann bromide degradation. If I just remove a CO from here, I get a NH2 directly attached. So option 3. Okay, very important reaction, Hofmann bromide degradation reaction. Moving on to the next one. In weakly acidic medium, homework question number 6. Tell me the answer quickly for question number 6 in the chat box. I already told you how to do, and tell me the answer of this one. Next one. Question says, aniline is reacted with bromine water and resulting product is treated with the aqueous solution of sodium nitrite. So when aniline is taken, we know it's highly reactive for ESR. So its reaction with bromine water is just like that of phenol. We get a white precipitate type NH2 tribromoaniline. Tribromoaniline. Then it is treated with sodium nitrite in presence of HCl, which is nothing but diazotization, where we get a diazonium salt like this. 2,4,6 tribromo benzene diazonium chloride. The compound so formed is converted into tetrafluoroborate, which is subsequently heated dry, which is a Ball-Scheiman reaction. Very important reaction, Ball-Scheiman reaction. Another name reaction, which gives you, so when I reacted with HbF4, this diazonium converts to a stable diazonium salt. This is a stable diazonium salt. Other diazoniums are not stable, but tetrafluoroborate, this diazonium, is a highly stable diazonium. When you heat it, finally, this whole group is substituted by a fluoride. So we get Br here, Br here, Br here, and a fluorine here. What is the final product? Is it a 135 tribromobenzene? No. Is it a parabromo? No. It's a parabromofluorobenzene. It's a 2,4,6 tribromofluorobenzene. A little bit of a tougher question as per NEET level, but it's a very old question, but can be asked. It's not a tough question as per you. This is from the NCERT. All the reactions are from the NCERT. Just that 3-4 reactions are done subsequently here. Okay, bromination, which is periodical, which is your electrophilic substitution, tribromination, diazotization, Ball-Scheiman reaction. Okay. The compound obtained by heating a mixture of primary amine and chloroform and KOH. Homework question number 7. In the comment box, you can tell me. Just now I have told you this test. It has a name. For the question number 7, tell me the answer and tell me what is the name of the test. Okay. Moving ahead. Again, same question. Isocyanide test, okay, prepared by carbylamine reaction. Next one. Aniline's activated system for electrophilic substitution. The compound formed on heating aniline with acetic anhydride. This is called as acetylation of aniline. So whenever we take aniline, we don't do its direct bromination, we do not do its direct nitration. Otherwise, products are not as per our requirement. Mono substitution products are not there. So first what we do is, we reacted with acetic anhydride and do its acetylation, which is just like a esterification reaction. H will go from here, CH3CO minus will go from here. We get this compound called as acetanilide. Acetanilide. Acetate group is here, acetyl group is there, aniline is there, acetanilide, which is the fourth option, acetanilide. Okay, I hope it is clear to you. I hope nobody is making this option thinking that it's a Friedel-Crafts reaction. Friedel-Crafts acylation, anilines and phenols do not undergo. Okay, so they instead undergo esterification and acetylation. Next is a coupling reaction. Whenever we take any activated ring like aniline or phenol, at the para position, coupling happens. So this is your electrophile. From here, the para position, it will attack on this nitrogen and this pi bond will shift ahead. So coupling gives you para-azo coupled product, which is this one. This is a yellow colored dye. It is a yellow colored dye. If it was a phenol, if there was the OH here, that is the orange colored dye. Okay, paramethyl diazobenzene. Moving to question number 48. Which is the most stable diazonium salt? I just told you the answer for this as well. This is alkyl diazonium. Alkyl diazonium. Alkyl diazonium. Still, benzyl is also alkyl diazonium only, no? So when your diazonium is attached to a sp3 carbon, it is never ever stable. It is never ever stable. This is your aryl diazonium. Aryl diazoniums are very, very stable. Means they are stable at around 0 to 5 degrees Celsius. So out of all of them, aryl diazoniums are most stable. Next one is when a primary amine reacts with chloroform. Again, same question I just told you. it gives you isocyanide. And moving towards the last particular question, an organic compound upon reacting with ammonia gives B. On heating, B gives C. C in the presence of KOH reacts with Br2 to give a primary amine. This is your last reaction is what? It is a Hoffman bromide degradation. So what is A? Okay, another good question. Let us see. If A was this, for example, would it react with ammonia? Yes, it will give you amide. CH3, CH2, CO, NH2. On heating, B gives C. Actually, without heating, you will not directly get a amide. You will get a salt of ammonium carboxylate, like this. Without heating, we get just the acid-base reaction. Ammonia is a base, acid is an acid. We get this salt. On heating, dehydration happens. H2 go from here and oxygen go from here, and we get a amide that you all know. Okay, and when we do Hoffman bromide degradation of this, CO will come out from here. We get a CH3, CH2, NH2. So yes, they were asking you to prepare only CH3, CH2, NH2 only. So it's absolutely correct answer. Means A is your correct option. Okay. So from going from a 3 carbons carboxylic acid to 2 carbons amine, this is the way we can go. Others are also going to give you some products, but this will give you a 1 carbon ka product. This will give you a 3 carbon ka product. It will give you a again it will give you a 3 carbon product, which will be isopropyl amine. So option A is the only option possible here. Okay, this is the last question we have. So we'll keep it till here. This is the last question. I want you to tell me, because I just told you the way to do the Hoffman bromide degradation. So whenever you are doing Hoffman bromide degradation, I will only tell this question as well. You require 1 mole of Br2 with 4 moles of NaOH here. So I'll tell you the product. You will get RNH2. Total 4 sodium hydroxides are there. 2 of the sodium hydroxide become Na2CO3, taking this carbon, and rest 2 become NaBr. This is the overall stoichiometry. You should remember for it. Okay, you must remember this particular stoichiometry as well. Okay, in that case, you will be able to do this question easily, and water molecule also will be there. Okay, 2 moles of water you can remove, Na2CO3, and 2 moles of water. Its mechanism is not there for the NEET syllabus, but if you want, you can do it. Okay, it's not a very tough mechanism, but not there for your syllabus. You can leave the mechanism part. And this completes our today's lecture. So we require 4 moles of NaOH, 1 mole of Br2, which is option 4. Okay, so I hope you have enjoyed this session and you are able to revise all your 3 topics that we have done today, which is carbonyls, carboxylic acids, amines, and diazonium salt. Okay, and thank you very much for watching the video. I hope you all will do great in your upcoming NEET exam. All the best. Bye bye. Thank you.